Hi, everyone. Welcome to the lecture for Chapter 9, which is going to be all about climate change and global warming. So our climate is changing, um, although some people don't think so. And so we're going to talk about, is the Earth's climate really warming? It is. And if so, who's to blame? And more importantly, what we can do about it. So the Earth's atmosphere is definitely warming. We can see that. We can take temperature. It's pretty easy to see that it is warming. Yearly average temperatures increase in the Arctic twice as fast as in the tropics and in temperate areas. So 90% of Arctic glaciers are retreating at very fast rates, which is problematic for a couple of reasons, which we'll talk about in a few minutes. Sea ice has been declining. Permafrost, which is this traditionally frozen soil that holds all of this organic material that has not decomposed yet, is melting. And when permafrost melts, it releases more methane, which causes more climate change. Fires are becoming more common. We in California have seen some pretty dramatic wildfires in the recent past. Animal populations are decreasing. We are now going through a sixth mass extinction. There have been five so far on our planet, and we are in the middle of a sixth. But public perceptions around climate change, particularly in the United States, are a little bit confusing. So in the US, 2016 study found that only 48% of people believe climate change is caused by humans, or that it is anthropogenic. And we are going to talk today about how we know that it's being caused by humans, that it's not just a natural fluctuation in the climate. And the opinion is very political in the United States. 70% of people agree, but less than 30% of Republicans agree that climate change is anthropogenic. And this was not always the case. When climate change was first really being discussed, kind of on the international and national stage, it was really both sides of the aisle that pretty much agreed that this was happening and that we needed to do something. And now it's kind of become this topic of political leverage. The international community and the scientific community, though, agree that this is happening. So we are, kind of unique in the United States that we have such a large percentage of the population that does not think that it is happening. Which I'm not going to get into much to in this class why that is, but this argument is not really happening. We had the 2015 Paris Climate Accord, which the Obama administration signed, and then the Trump administration pulled out of. So definitely a different ideas between administrations about climate change. So we can see that glaciers are retreating. So most of Alaska's glaciers have been retreating at unprecedented rates. So 50 years ago, this glacier extended all the way to the shore of the lake in the foreground. And now it has decreased quite a bit. Again, that permafrost that is melting that frozen ground. This is a picture from in Canada. This is also happening in Alaska, where you have structures collapsing due to this permafrost melt. Sea level rise, right? This is low-lying parts of Miami, Florida, during high tides and storm surges. So this becoming more common. Florida is particularly in trouble with concerns to climate change. The highest point in Florida, I believe, is about 310 feet above sea level. Much of Florida is very, very low lying. I want us to understand, though, the difference of weather versus climate, because especially with discussions around climate change, people kind of confuse weather events with climate change. And so they will use one particular weather event in order to say there's no climate change. But weather is present atmospheric conditions. So right now, as I record this lecture and I look out my window, it's about 67 degrees, it's sunny, not a cloud in the sky. Southern California is a pretty nice place, but weather changes constantly, right? Um, the weather is slightly different every day. It can be dramatically different every day, but those are individual atmospheric conditions. As opposed to climate, we're talking about average atmospheric conditions and seasonal patterns. So we're talking about things like your annual high temperatures, your annual low temperatures, your annual rainfall, right? We're looking at long-term averages. And these things change very gradually, and they tell us a lot about a place. So in Southern California, Mediterranean climate, we have hot, dry summers and cooler, wetter winters, right? That is our climate. So while this could be the weather in Las Vegas, where it is snowing, this is a little more indicative of the climate in Las Vegas, right? Generally, kind of a hot and dry place. But you wouldn't look at that one snowstorm in Las Vegas and be like, oh, that means that there is no climate change. Another way to look at it, which somebody explained to me many years ago, was if you think of it in terms of baseball, metaphor of baseball, if you have a pitcher, a really good pitcher, he is going to throw a certain amount of strikes. If he starts taking steroids, he is going to throw more strikes, but you're not going to know which individual strike was caused by steroids and which one wasn't. So we are having stronger, more intense tropical storms and hurricanes, but you can't really point to a particular tropical storm and say that one is definitely climate change, but the amount and the intensity of them is on the rise. Something else people misunderstand about climate change, and you're going to watch a short video on this, is people will say, well, the Earth has been hotter before. And that is definitely true. So we have three graphs here. The top one is the Earth's temperature over millions of years, then over thousands of years, and then over the past 1,000 or so years. And so, yes, the Earth was definitely warmer at other times. Our big concern is this rise in temperature that happens, that coincides with the Industrial Revolution, when we start burning fossil fuels and releasing these gases into the atmosphere. So it is that period of time that we're very concerned about. The other thing, and what the video you're going to watch is going to talk about, is basically about 10,000 years ago, the climate stabilized. So you can see over thousands of years, you have this really kind of, fluctuation in temperature. And human beings as a species have been around for quite some time. But it was only in the past 10,000 years that when the climate stabilized, we had the birth of civilization and agriculture and settlements and cities. And so it is really, we are very dependent upon this stable climate. And so it is really us who is going to suffer, along with a lot of, a lot of ecosystems. But this is particularly why we should be concerned about it. So how do we measure global warming? So recent climate change, the Earth has warmed significantly since the Industrial Revolution. As I showed on that previous slide. And it is difficult to measure annual surface air temperature. It can be challenging to measure this over the entire planet. Even so, we have temperature stations all over the globe in which we measure that, and then we can use modeling. So again, sampling stations, and then we can use modeling to extrapolate kind of the points that we don't have. And we can see temperature anomalies. We can see that it is going up. So just this past year, Scripps Oceanography who has been taking water temperatures off the coast daily for quite some time now. It is the warmest water that they have seen. And then we also have stationary buoys over sea, which we use to measure air temperature. And then we can also use satellites in order to measure temperatures at sea. But when we look at kind of those global land and ocean temperature um, anomalies, so this is for the month of November, um, so we can see that zero is kind of the average mean, and we can see going back that we were kind of below the average mean, and now up, 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 and up. So all the hottest years in recorded history have been in the past few years. And again, we're looking at global average temperatures. And something else that people will say is, well, there's natural climate variation. And that is true. There is natural climate variation. There are things that can cause the planet to um, be warmer or cooler depending on when it is. One is solar forcing. So how much radiation the Earth is getting from the sun, and that can vary. We also have something called Milankovitch cycles when we are slightly closer to the sun, but we know that that is not what is causing the temperature change now. We also have regional variations and annual temperatures that can vary, especially with concerns to variations in temperature on land versus water. Then we also have something called the El Nino Southern Oscillation, which you might hear we're in an El Nino year one year or we're not. This is changes in ocean currents that can alter weather patterns, which happen so many years. El Ninos have been going on for quite a while. El Ninos are also becoming more frequent. That is a kind of a big change in climate. And then we have volcanic eruptions. Large volcanic eruptions can throw large amounts of debris and ash into the air that can actually contribute to a cooling atmosphere. So again, here is El Nino. Here is looking at the waters of the Pacific during a El Nino as opposed to a La Nina year. And you can see here much, much warmer water. For example, this is Mount Pinatubo in the Philippines, which erupted in 1991 and spewed quite a bit of ash into the atmosphere and affected global temperatures for about 2 years. But we know we have a good idea of how those things work, how much temperature variation they can cause, and they do not cause the level of climate change that we are seeing today. So what causes global warming? And I want to be clear that global warming and climate change are like slightly two different things. The Earth is warming, that is causing climate change. So it doesn't mean that everywhere is automatically going to get warmer, but as the Earth gets warmer, it is causing the climate to change. And so one of the reasons, or the main reason that this can happen, is something called the greenhouse effect. We need the greenhouse effect on this planet. The greenhouse effect is great. It's what makes our planet habitable. But what happens is we have incoming solar radiation. You can see number one there. That comes in, and then the Earth absorbs some of that solar radiation and it re-emits it as infrared radiation. So it takes some of that heat and then bounces it back. And then some of that infrared radiation escapes back to space. Some of it is absorbed by the greenhouse gases in this layer over here. So some are absorbed by greenhouse gases and they're pinged back to the planet and then they're pinged back up. Some will escape again. But we know that gas molecules absorb heat. We know that such gases are called greenhouse gases. Water vapor is the most abundant naturally occurring gas, not necessarily the one that we're concerned about. The two that we're really concerned about are carbon dioxide and methane. So carbon dioxide And methane when you are burning organic materials, fossil fuels, or when you have that permafrost where you have that um, plant life that is stuck in that frozen permafrost that then starts to decompose and releases methane. And then we also have nitrous oxide. But basically, it traps the heat from the Earth's surface. And so we are trapping more heat in this blanket. Less is able to escape due to that increase in greenhouse gases. And we know that there is more CO2 in the atmosphere. We've been taking CO2 measurements, right? So we've increased CO2 emissions quite dramatically in the past 120 years. And we can measure CO2 concentrations in the atmosphere. These measurements were taken at Hawaii's Mauna Loa Observatory. And when you see these little squiggles back and forth, what's happening here has to do with seasonal variation, where you have more vegetation, more primary productivity, and therefore more CO2 being absorbed by plants. But we can take these, we've been taking these consistent measurements since the before 1960, and we can see the rise in CO2 levels. In addition, we can see the rise in nitrous oxide and methane, which are a consequence of human activities such as deforestation, agriculture, and the burning of fossil fuels. We started taking those measurements of those gases in and around 1975. And so when we look at what are we doing in order to contribute to these greenhouse gases, a huge portion, 25%, is electricity and heat production. Then you have transportation is another big chunk at 14%. We have land use and agriculture. Agriculture is a very intensive greenhouse gas emitter, particularly livestock and methane production. Then we have industry, fossil fuel retrieval and processing, and finally buildings. And then we also have an understanding of who is emitting greenhouse gases. Most places are emitting greenhouse gases, but at vastly different levels. So China is responsible for about 30% of the emissions. The United States is responsible for about half that amount with a lot fewer people. Our per capita emissions are much higher. And so if you look at India, much less of the world's global emissions, despite having a comparable population to China. And you can see, several countries have had their emissions go down since 1990 compared to 2013. Ours have gone down a little bit. The world globally has gone up, though. This is especially true as people kind of get out of poverty, have higher levels of consumption, more automobile use, but generally speaking, the highest contributors per capita are places like the United States, parts of Europe, but what we would consider the most developed countries. So what are some of the consequences of global warming? Well, first we have climate patterns changing. So some places are drier and some places are wetter. And again, we have become really dependent upon these stable climates. And so, we just came out of a major drought in California. You have other places in the Midwest that are experiencing lots of flooding. Then you have melting glaciers and ice sheets. So as I said before, 80% plus of the Earth's glaciers are retreating. And so this is a problem because it actually increases climate change. It has one of these positive feedback loops. But then we also have sea level rise happening. Sea level rise is happening for two reasons. And the first one we usually think of is glacial meltwater. And while that is contributing to sea level rise. By far the bigger one is thermal expansion. And as ocean temperatures warm, when you warm something, it expands. So as that ocean temperature warms, you have this rising of sea levels. And so this picture here is from the country of Maldives, which is a very low-lying country. And to kind of make a statement, they held a cabinet meeting underwater a few years ago to talk about climate change. But generally, these low-lying places are really going to potentially disappear as climate change progresses. And we can see, snow cover has been reducing every year pretty dramatically. We also have parts of the Antarctic ice shelf collapsing at a much faster rate than we had thought. In 2017, an iceberg the size of Delaware broke off from the ice shelf. And we can see this change in sea level, right? We can see this change as sea level rises year to year. So things that are quite easy to measure. Other consequences of global warming vary from region to region and place to place, but you're going to have changing populations and ecosystems. Climate is key for ecosystems. If you look at a global climate map and a global vegetation map, they line up quite nicely. Climate change can be cues for animal migration and also for plant physiology. Depending on when it gets warmer or when it gets colder or when the rains come or when this happens, different species have cues to do different things. So for example, warmer spring temperatures across Europe cause insects to mature earlier. And as a result, the migration of these birds here from Africa no longer match up with when those insects mature. And so that leads them to have insufficient insufficient food, for their young. And so their populations are decreasing because now they are out of sync. They have evolved to migrate when there is this maximum amount of food. And this affects both terrestrial and aquatic systems. I'm going to give you an extra credit opportunity on this module to watch a film called Chasing Coral, which is all about coral reef and climate change and how that is being dramatically affected. And the IPCC, which is the Intergovernmental Panel on Climate Change, estimates that there are likely to be different levels of effects on different systems as a result of global warming, but you have different amounts of rainfall underwater, ecosystems. We're facing now widespread coral mortality. Food systems are being disrupted, increased damage from floods and storms, and then also increased morbidity. Right, you have people who are affected from heat waves and floods and droughts, and also affecting some disease vectors that can often happen in unpredictable ways. And so, how do we mitigate, or how do we deal with these big changes that are happening? And we want to think about how do we practice efficiency and conservation, right? So how are we being most efficient with our resource use and also conserving? And so your book talks about Pacala and Socolow, and they propose action in 4 areas. The first one is transport efficiency, so improving the miles per gallon that we are getting out of our automobiles. And then transport conservation, right? So the amount of energy that's used per person for trains and buses and all types of other public transportation here is the subway in DC, right? But generally speaking, we want people to use mass transit. We want to see a reduction of traffic. We also want buildings to become more efficient. SDSU's relatively new student center now is a LEED certified building. It is a much more efficient building. And then we want efficiency in electricity production. So coal burning power plants produce about 65% of the world's electricity, and they account for about 25% of their emissions. So how do we become more efficient in our electricity production? So again, fossil fuel use, we want to change the types of fossil fuels that we use and ideally use less fossil fuels overall. But when you think about coal versus natural gas, coal emits twice the CO2 that natural gas does. So if you're going to use a fossil fuel, natural gas is a much better option. And then there's something called carbon capture and storage, or carbon capture and sequestration, it's also called. But that's basically where you have a power station here, it's releasing CO2, you're capturing it, and you are storing it underground. And there are some problems with this in that I think there's only one place in the United States that's been able to do it so far. So the technology and the funding for that is not really there. A few years ago, actually more than a few years ago, probably over a decade now, people were talking a lot about clean coal technology. And not that we should invest in clean coal technology, but it's not really there. It's likely not to be kind of our long-term answer to this problem. Um, we want to switch to renewable energy like solar and wind, biofuels, which some biofuels are not great. They emit large amounts of CO2, but wind and solar are not emitting CO2. So they produce little or no, sometimes with the manufacturing. But right now, less than 1% of wind energy, or less than 1% of energy globally is produced from wind energy, and we really want to increase those. And then we have nuclear energy, which emits very little CO2, but there's a lot of safety concerns. Here's a picture of San Onofre, which is very close to where I live. I live in San Clemente, which is the first thing north of the base. So quite there. There is, basically toxic waste on site, even though that facility is no longer operating. What happens if there is a leak or there's a tsunami? We are an earthquake zone. A lot of people where I live in my town, this is one of their top concerns, having this in our backyard. And then also, preserving biostorage. So what do I mean by preserving biostorage? We have lots of carbon that is stored in forests and in soil, and we want to keep it there. We do not want to let it out. Deforestation leads to this increase in climate change. But climate change is happening. So how do we adapt to it? And I'm not saying that we shouldn't keep mitigating, but it's definitely happening. There are, this idea that, we've committed to warning, it's inevitable change. So how do we deal with things like a drier climate and drought in certain places? How do we ensure we have sustainable water supply? When you think about agriculture, this is a situation where you have this drip irrigation that is really efficiently using water in this picture here, right on the root of the plant. So as little is wasted as possible. On the same hand, you need to deal with increased rainfall and flooding in certain places. It's also not good for your crops if they're getting too much water. And then also heat. Crop losses due to heat. Certain things that we grow want to grow in certain temperatures. Um, and then we also have concerns with fire. In addition, again, looking at that committed warming equals inevitable change, patterns of storms, so increased hurricanes and tropical storms, putting coastal areas very at risk. Coastal areas are also highly at risk due to rising sea level. And then also saltwater intrusion into groundwater. So if you are using groundwater, which lots of places are, and as that sea level rises, that groundwater can become contaminated by salt water. And when that happens, you are going to you lose your ability to access that fresh water source. And there are regional differences. So the capacity to adapt is not evenly distributed. Low-lying places that are generally poor are not going to have the ability to adapt as quickly or efficiently. And in the United States, places, again, like Florida, this is property loss potential, and it's by county. So there we are. Right, we are facing large losses due to climate change, but all of these low-lying coastal areas, especially in the Gulf, are going to have to deal with this. And so what are some policies that we use in order to adapt? And so, oops, excuse me. Go back. My mouse got ahead of me. So what is the cost of adapting, to try to mitigate this climate change? So if we move from business as usual, which is what we're doing now, to a sustainable system, it's going to cost the United States 1 to 2% of their GDP or gross domestic product, which is between a little over half and $1.3 trillion. So that's not a small amount of money. But if we stick with this business as usual, we are going to lose more than 4% of our GDP, $2.6 trillion. So economists, argue that we are being very short-sighted, that we are going to have much bigger losses moving forward if we don't deal with this problem now. And so some policy alternatives that we use to try to deal with this are regulations, such as rules to reduce CO2 emissions. So we have something called the corporate average fuel economy, and this is regulations regarding automobiles and how much mileage per gallon. The current standard for automobiles is 27.5 miles per gallon, and this is going to increase to 35 miles per gallon by 2020. Many cars now already get 35 miles to the gallon, but again, telling auto manufacturers that you are going to have to increase your fuel efficiency. Also, economic incentives, giving people tax credits for adopting mitigation measures. And then cap and trade, which is a system by where only a certain amount of emissions are allowed, and businesses can trade those emissions, ones who are releasing less to people who are releasing more, but basically capping the amount of emissions that businesses are allowed to emit. And in 1992 at the Earth Summit, this is President George H.W. Bush on the top with his wife, so not the second President Bush, the first one. He signed the Earth Pledge, which was a commitment to protect the Earth's environment, encouraged nations to take actions that would reduce the threat of climate change. And then in Kyoto, Japan in 1997, UN members agreed to reduce emissions to 1990 levels by 2010. The United States signed it there, but then failed to ratify it in our Congress. So basically, if you have an international treaty, you can sign it, but then our Congress has to ratify it. And we did not have the votes to get that ratified in Congress. So, an important thing is, when we're looking at international agreements, we need to have consensus among nations. This is a global problem, and it is going to take a global effort in order to solve it. And so the United Nations Environmental Program established the Intergovernmental Panel on Climate Change, the IPCC. And, they have put out a series of reports that, state warming is a direct consequence of human action. Again, people say that the scientific consensus is not clear, and that is not true. So again, we had the Earth Summit, we have the Kyoto Protocol, we've had several climate change conferences. The Paris Climate Accord had much more aggressive emission targets, and the targets were based upon country. And again, we signed it, and then we pulled out of it. And so again, that Kyoto Protocol, when we were trying to get back to 1990 emissions, most places were not able to do that, right? So the Paris Climate Accord, again, is much stricter about how that is going to work and how we are going to reduce emissions. But the United States is not in it anymore. If you were in my online physical geography, I would have you write about the Paris Climate Agreement. But, these things are often very administration based, which is difficult because, again, we are a huge emitter of greenhouse gases, and we really need a global strategy in order to do this. So that is the end of the lecture for Chapter 9. You're now going to proceed on and watch two short videos, one about that stable warming in the past 10,000 years, because I really want you to fully understand that, and one also about the recent protest that we had over climate change.